All right, so this section is 8.1. We're adding and subtracting polynomials. Polynomials will be defined for you very soon, but we first want to go through a couple of these definitions that you may not know that make up polynomials. A monomial, so a monomial is a number, a variable, or the product of a number in one or more variables with whole number exponents. And you see examples of monomials right here. Okay, they're basically a single term. And then the degree of a monomial is going to be the sum of the exponents of the variables in the monomial. And again, this shows you what the degrees would be. No power here, so degree 0. Power of 1 here, so it's 1. We have a power of 1 on the A, that's 1. We have power of 2 on the B, 1 plus 2 is 3. And then the exponent on the M here is 5. Okay, so this tells you things that are not monomials. Okay, it says the degree of a non-zero constant is 0, and the constant 0 does not have a degree. So that's important to know. And then down here is where we define a polynomial. A polynomial is a monomial or a sum of monomials, each called a term of the polynomial. So you should write down each of these definitions. If you need to pause this video to write it down, then do that quickly. And then go ahead and hit play when you're ready. So if we're going to classify a polynomial, we will always classify it by its degree. The degree will be the greatest degree of its terms. So we were saying here that this is the degree, like this is 2 or 3 in this case, or this is 5. When you look at a polynomial down like we have below, it's a collection of all these monomials. Real simple. What we do is this is degree 3, this is degree 2, this is degree 1, this is degree 0. The degree of a polynomial will be the greatest degree that we have, which in this case is 3. Essentially, you're looking for the highest exponent. The largest exponent that you have will give you the degree. The leading coefficient will be the leading number in that first term that has the degree on it. Okay, so because this is the highest exponent, the number that's out in front will be called your leading coefficient. And you write it in order. So notice it goes from highest degree down to lowest degree, and that's the way we want to write it. Okay, so here's what we're going to do. Let's first classify. Let's look at this example. Do this very quickly. It says a polynomial with 2 terms is called a binomial. A polynomial with 3 terms is called a trinomial. And polynomials are classified by their degree and number of terms. So in this one right here, we want to first rewrite it so the exponents decrease from left to right. So we want this one to go first. Make sure the sign goes with it. Notice the negative comes with it. Negative 4b to the 4th plus 3b to the 3rd minus 6. Because there is 3 terms there, we're going to call this a trinomial because there's 3 terms. The leading coefficient is just the number that's in front of the highest degree. So the leading coefficient is negative 4, and the degree is just 4. Why is it 4? Because that's what this power is right here. Okay, that's the highest power, so it's 4. The leading coefficient is right here. Okay, so name it trinomial because there's 3 terms. Leading coefficient is the number in front of the variable that has the highest power, and the degree is the highest power. Okay, so let's move on to another example. So we're going to be talking about adding and subtracting polynomials, which actually should be really easy for you guys because really all we're doing is we're doing the same thing we've always done when combining like terms. We look for the like terms and we combine only those. So what we're going to do is you don't have to, you can rewrite these first if you want, and sometimes that makes it easier. So the first thing that I'm going to do is I'm going to rewrite this term so that way the highest power is first. So negative x to the 3rd minus 2x squared plus 3x plus x to the 3rd plus 3x squared minus 12. And then when I add polynomials, I'm just simply going to add my like terms. Negative x to the 3rd plus positive x to the 3rd. Always put a plus in between. And then we have negative 2x squared plus 3x squared. plus, and then 3x, then we have 3x plus, there is no 3x over here, so it's just 3x plus 0. And then over here we have no constant, so it's 0 plus a negative 12. And then all we do is combine our like terms. These two cancel out, so there is nothing. Negative 2x squared plus 3x squared is a positive x squared. 3x plus 0 is just a positive 3x. And 0 plus negative 12 is negative 12. So there we are. Okay, so what I want you to do is down here, we're going to skip this one for now. Let's go down and let's look at this example right here for subtracting. Now, when it comes to subtracting, there's a couple things that you can do. The way that I like to see students do it is I like to see you set it up vertically. Vertically means I'd like you to put this right below it, like you were subtracting, vertically, straight up and down instead of to the side. And the reason why I will do this is I'm going to rewrite this to show you. Anytime I'm missing a term, I will always put 0. I've got to put a placeholder there. So I'm going to rewrite this as 2c squared plus 0c minus 8. And then right below it, I'm going to minus, and we're going to do 3c squared minus 4c plus 1. And I'm going to put this in parentheses. Now, here's the number one thing that you have to pay attention to. It is always minus. 2c squared minus 3c squared is negative c squared. 0c minus a negative 4c. Don't just do 0 minus 4c. This is 0c minus a negative 4c, actually is a positive 4c. And then negative 8 minus 1 is negative 9. Okay, and there's your solution there. Okay, so you have 2 checkpoints, or you have 3 checkpoints that I want you to do. One is identifying, like what we did on the first page. The second one is finding the difference, and they're already lined up vertically for you. Just make sure you put in your placeholder there. And then the last one is finding the sum. So do those on your own. Hit pause on the video, and then hit play when you've done these 3 to see if you've done them right. Okay, so for the first one, if you rewrite it in order, you have y to the third minus 4y plus 3. There's 3 terms, therefore it's a trinomial. The leading coefficient in front of our y to the third is 1. If there is no number, it's 1. So we have to remember that. And the degree is the highest power that we have, which is 3. The second one, you had to remember to add the plus 0 at the end here and subtract each one separately. 4 minus 5, negative 1, x squared. Negative 7 minus 4, negative 11. 0, because there's nothing there, minus a negative 9 is going to be a positive 9. Okay, so just got to be very careful when we're doing that. Okay, last one. Again, combine your like terms first where you can, and then put in your placeholders. So I have the top one is 5x to the third plus 0x squared plus 2x plus 0. And then 0x to the third plus 4x squared plus 0x minus 6. Again, the 0 terms just come from where there's nothing shown up above. So the 0x squared, there was no x squared term. That's where that came from. So what you should have been left with is 5 plus 0 is 5, 0 plus 4 is 4, 2 plus 0 is 2, and 0 plus negative 6 is negative 6. And then this should have been what you get for your final answer. Okay, last thing. So, this is just a story problem. It says, during the period of 2006 to 2012, the average number of hours a person watched broadcast television and cable satellite television can be modeled by these 2 equations. So this right here is broadcast television. This is cable and satellite. We want to know the total number of people that watched in 2011. Well, if we want to know the total, we would do this plus this. So that's all we're going to do is we're going to set this up so it's just an addition problem. So we're going to add the 2 together. So it's going to be 2.8t squared minus 35t plus 879 plus negative 5t squared plus 80t plus 712. And then we're just simply going to add those up, and we end up with negative 2.2 t squared plus 45t, because negative 35 plus 80 is 45, plus 1,591. So there's our equation that models this. Now it says, how many hours of total television did people watch in 2011? Well, what you need to do is, because we started in 2006, you need to figure out how many years have passed in 2011. Well, because 5 years have passed, so from 2006 to 2011, so you would do 2011 minus 2006 equals 5 years. So we're going to take this 5 and we're going to plug it in for t. So negative 2.2 times 5 squared plus 45 times 5 plus 1591. And you just plug that into a calculator and you will get 1,761 hours. Okay, so that is it for this section. Bring questions to class, and don't forget, if assigned, to take your Edmodo quiz if that has been assigned. See you then.